We could go on doing that ad nauseum, copying keyframes and then dragging our feet and torso forward, but that would be a pretty boring way of getting a lot of footsteps. Let's do it easier. First of all, I'm going to extend our timeline, let's say 300 frames. Hit E to make that the end frame in the timeline window. And then let's see what we do to get it going longer. First, I'm going to change the action name to something more obvious, like forward cycle or something like that, or forward walk. And now we're done with the action editor right now. We're going to switch to another view, and that is the NLA editor, which stands for nonlinear animation. And if you're familiar with dope sheets, then it's maybe a little closer to a dope sheet mixed in with the functionality of a video editor, but working on animation instead of working on video. So we're going to transform our forward walk cycle into a clip, or in Blender terms into a strip. And so since we have the armature selected here, so we can just hover our mouse over here in the NLA and type Alt-C and click on forward walk to NLA strip. So there you go, Alt-C, forward walk to NLA strip. And now we have a strip in the NLA which is already selected and highlighted. We'll change the timing of the action to NLA mode by clicking on that little picture next to the name of the armature. And now it's showing the NLA icon, showing us that it's showing us the NLA timing, which currently is the same as the timing because we haven't changed anything yet. So now we have the strip. Now we could move it around and scale it and do things like that to make the walk slower and faster, or take longer. But if we hit the N key, we can find all sorts of interesting properties for it. It's a transform property similar to the one you find in a 3D view, only applies to the NLA strip itself. You can see the start and end for the strip and for the action, and they're locked together automatically right now. But you also have a lot of nice things like a repeat number for how many times the thing cycles forward. So let's make 10 steps, for instance, and let's say it has to take 10 times longer, so we can actually multiply the strip end here by 10. But first, since it's starting from frame 1, I'll do 1 plus the length of the whole plus 10 times the length of the whole thing, which is 24. And so now it's 241 frames instead of 25 frames. You could have done it just by scaling in the NLA itself, but it wouldn't have been precise. So now if you play it, he's moving forward really slowly, which is awesome. Mancandy on the moon. I really like that, actually. But we really don't want that. We want him to walk at the same speed, more or less. So let's click on this little repeat button and have him repeat the action 10 times. And you'll see that you have 10 little segments here, and the motion speed is back to normal. But look what happens when we go over that limit there. Over each division, something bad is going to happen. And he basically just jumps back to the first frame in the action because Blender doesn't really know that we want him to move forward. It doesn't have information about forward and character and such things. So let's have a look at one of these special bones that we kept on moving around, the torso or the feet, that were getting offset forward each time we copied the action. And let's tell Blender to do the offsetting for us on the whole action. So if you look at the transform properties over there, you can see the name of the bone is torso, and you can see that it's getting offset by about 2 or 4 rather every time the action moves. So we'll copy the name of the torso bone here, and we'll type it into where it says offset bone in the transform properties for the strip. And now let's see what happens as we scrub forward. And you notice that the character doesn't jump back anymore. Blender is using the offset that it figured out from looking at the action file itself, action strip itself, and applying it to each subsequent repetition of the action. And finally, we have a character that moves forward with each step without having to do anything complicated.